I'm Hassan. In this video, I want to talk about ADC as a peripheral and how we work with that. At first, I prepare a document for ADC. ADC is embedded in STM32 microcontrollers use SAR, and this is the ADC in STM32. The main point is here 12-bit for resolution. The resolution is the ADC is 10 channel 12-bit ADC. Here the term 10 channel imply that are 10 ADC pins using which we can measure analog voltage. Okay, this means 4096 is about the number of resolution. We can use this formula. You can see distance steps equal voltage divided by this step or reference voltage. In our ST micro, reference voltage means 3.3 divided by 4096. This is the example of it. You can see that 8.056 millivolt per unit. It means when we have 7 millivolt, the micro is cannot change or conversion to ADC. It must be upper than this number, as you can see. Okay, next part, the result of formula called distance steps, and this is the diagram for analog and digital is comparing when we have this wave for analog, and you can see that this is this analog wave, and digital it means some places 0 and other places 1. This means the digital, and the next part is about distance steps between two line. I mean, this is the distance steps we calculate in the last item. How a long signal is converted into digital format. As you know, the computer digital value is almost 1 or 0. So as long we output to convert into digital value for processing conversion need to accurate. When we input analog voltage is given STM32, it means the voltage variable between 0 and 3.3. As you can see that this is the formula. We can change the uh, analog to binary. This is the ADC value. We read it in decay for some register, and the divided by ADC resolution is 4096. As I say, we have 10 channel for ADC, and the resolution is 12, and 2 power 12. It means 4096, and its cross to reference voltage is 3.3 voltage. And the other thing I was to talking about that sampling time for ADC T-rated sampling time plus 12.5. If sampling time is 1.5, 1.5 cycle plus 2 12.5, it means 40 cycles. If ADC clock is 4 mega and the T or the time of sampling is 40 divided by 4 million clock, it means 3.5 microsecond. 3.5 microsecond, it means we have sampled the input signal to this time. This is the meaning of sampling time. And this is the note in here. We have a number of conversion I will show in the STM CubeMX. When we use ADC channel 0, it means a number of conversion must be 1. And when we use ADC channel 1, number of conversion must be 2. And this is the schematic of my board I implied in the board. You can see we have a potentiometer in here, two pins 1 and 3 connected to ground and 3.3. It's not important how it's implied. And between two pins, I mean this yellow wire connected to PR0 or PR1. It depends on which channel you use in ADC and you want to choose it. Okay, go to the CubeMX and make the project. Okay, choose your micro. I use STM103, STM F103C8. Excuse me, 103C8. Okay, first of all, we go to the system core and change system to debug to serial wire because I used to debugger part. After that, go to the analog part and choose, for example, ADC1. After you click here, open there, and in this sample we use channel 0 and channel 1 to uh, active ADC. Okay, next go to the conversion mode, and number of conversion we can change it to 1 or 2. It's depend on uh, as I say in this part, ADC channel 0 is number of conversion is must be 1, and if you use ADC 1, the number of conversion is must to be 2. This is the important. I change this part to number of conversion 2, and the other part is the rank. This is the cycle and channel, and the other one is, for example, here rank, and the sample is, for example, like this. It's not important. It's for internal communication in ADC part. We can talk about here and change to channel 1 in here. This is it. And okay, everything is okay. Go to the project manager and make the project. For example, the name is ADC sample. Okay, and save in the desktop. Okay, ADC sample in here. Choose the Kale version and copy only necessary libraries. Everything is alright. Okay, I want to show this configuration. PR0 is connected to channel 1 ADC, and PR1 is connected to ADC1 channel 1. This is the important. After that, generate the code. Well, open the project. Okay, go to main.c and compile it again. Uh, mm, I write this code before I rest the film, and I copy the code in here. After that, I explain what happening here. Okay, at first we need to define a variable as a float in here. Okay, this is the float. After that, go to the while loop and use this part. Okay, at first we initialize the number of conversion. For example, this is the 2 because I want to use ADC channel 1. This is really important. And after that whole underline ADC underline init, it means which ADC we want to use that. The next part is the start ADC, as you can see that. And this part is really important. We have a condition in here, all underline ADC underline poll for conversion. This is the number of ADC I use, and this is the number the ADC send or conversion until their point. After that, it's equal to hull okay. Hull okay, it means ADC work completely, and we don't have problem in here. And we read the value of ADC and transfer to value. After that, the value divided 4095, it's about resolution bit, as I say. After that, we cross the 3.3. It's related to uh, reference voltage, and that part is stopped ADC with a delay at the end of that. Go through the debug setting, flash ticket here, and okay, and the next, compile this program on board. Okay, this is my board. We have a potentiometer in here. You can see that. I use this black wire is connected to ground, and the red wire connected to 3.3 voltage. It means VREF runs, and the orange wire is connected to PR1 because the number of conversion is 2. I choose, and we must use to ADC channel 1. If we want the channel, we must change the number of conversion to 1, and we can use the ADC channel 0. Next, I will show that how we can change the ADC channel. Okay, uh, build, go to debug part, and okay, find the value, click here, add to watch 1, and then omit this tick because we want to see the number of that. Okay, then compile, and I want to show what's happened in here. Okay, when I change the volume, you can see that the value is changed until maximum voltage. This is the maximum voltage, and when decrease the potentiometer, you can see that 0. Again, I increase this part, and again we have this part. Okay, and go back to the this part and change the number of conversion to 1, and we must change the pin PA1 to PA0. uh, okay, I changed the number of conversion in here to 1, as you can see that, and change PR1 to PR0. uh, this is the I changed this wire to PR0 before the code is installed to or connect to PR1, and to this count for this number of conversion, I mean 1, we must use ADC channel 0. It means we use P as 0 here. Okay, go back to the code, compile, then go to this part and run again. As you can see, when I change, you can see the voltage of potentiometer is exactly changed to until 3.2, 4, and 6 and 9. When I decrease that, you can see the 0 here. Okay, this is the ADC and how you use that. Thanks for watching me. Please subscribe my video. Bye.